Example number 72. Determine the position of the centroid of the area enclosed by the curve y is equals to 6x squared, the y-axis, and the ordinates y is equals to 1 and y is equals to 8, correct to 3 decimal places. So, how are we determining the position of the centroid? So remember, even if you sketch, if we just have a rough sketch here for explanation of this, if this is the Cartesian coordinate system, look at this. This is the y-axis, this is the x-axis. So you see this curve y equals to 6x squared is a parabola, isn't it? How does that parabola move? It means if you find the square root on both sides, you get x to be square root of root 6x to be the square root of y, isn't it? So when you have the square root of y, meaning the value of y must be positive. Are you seeing that? For the value of y to be must be positive, meaning this parabola is curving along the positive y-axis. You know how to sketch the parabolas. Remember when it is just 6x squared, when it was a parabola like y is equals to 6x squared plus 3, meaning it is a parabola curving along the y-axis but starting at point 3. At the ordinate 3. Are you seeing? When it was y is equals to 6 squared plus 2, it is starting at plus 2. When it was y is equals to 6 squared minus 2, it means... Are we together? So, that is not the most important thing, because you've not even told to sketch the parabola, isn't it? I'm only sketching it for that explanation. So the parabola y is equals to 6x squared, it means it is parabola curving along the y-axis like that, isn't it? So this is the parabola, y is equals to 6x squared. It is usually general, y is equals to ax squared. A can be any constant, isn't it? Are we together? Are we together? Good. So once you sketch that parabola, then you'll be told the region enclosed, the area enclosed by this parabola, the y-axis, and the ordinates y is equals to 1. So you put the ordinates y is equals to 1, which is somewhere around here. Y is equals to 1, and the ordinate y is equals to 8. So if you sketch that, this is where y is 1, and this is where y is 8, and this is the y-axis, and this is the parabola y is equal to 6x squared, you can see the region they are looking for is that region. Are you seeing? Are we clear? Yes. That is just a rough sketch, though they are not interested in the sketch. I was just using that for explanation. Are we clear? So the centroid, the position of the centroid is like the center of this shaded region. Are we together? The center of that shaded? Is that understood? Now, if you're looking for the center of this shaded region, you can see from it is there, it is denoted in the form x bar, y bar, isn't it? So you can see x value is that. Are we together? Then the y coordinate is the y bar and the x. Are we together? Is that okay? So you ask yourself, how are we determining a centroid? X bar and y and y bar. Is that okay? How do we determine? So we say the formula of getting the centroid is, if it is along the x-axis, we derive the formula by using the x-axis, isn't it? And we found that when you are looking for the x bar, the x coordinate of the centroid, you just put area over area, isn't it? Area over area, so if you are integrating from a to b, f of x dx over, you are integrating from a to b, f of x dx. Now from here, if y is a function of x, it means where there is f of x, you put y, isn't it? So if you're looking for x bar, you simply multiply the numerator with x. That is what we're saying. Are we together? You simply multiply the numerator with x. That is when you are integrating with respect to x, isn't it? What about when it is you are integrating with respect to y? Are you seeing that? What about when you are doing it with respect to y? See, when it is with y, it is y? No. When it is with y, what it simply means is that where there is x, you put y, where there is y, you put x. See, that is what it means. It means here we have x, we put y. Are you seeing what I'm saying? What I'm doing? It means here we have x, we put y. It means here we have y, we put x. It means here we have x, we put y. So it is x, y, dy. Here we have y, we put x. Here we have x, we put y. Have you seen? Have you seen the explanation I wanted to make? Because I told you a case when it is with respect to x, isn't it? But this our problem is with respect to y because the limits are for y, meaning it is with respect to y. Are you seeing that? So it means the y bar is not a half. You can even see the y bar, a half is inside. Look here, a half is inside and a half is outside. This half is which is outside is approximately this part which is here. So you see the y bar is taking definition of x bar if it was with respect to x. Are you getting the explanation I'm going to make there? Have you now seen it, Danny? You've seen it clearly now, isn't it? It's very good. I like that. The y bar is now taking the definition of x bar because it is. Have you seen that? Very good. I do like it when you understand concepts. When you understand concepts. So, we've seen clearly by definition that the y bar of the centroid is just we are integrating from a to b of xy dy over a to b of x dy. So let us now look for the x bar, isn't it? Yeah. Are we together? Yes. Good. Let us look for x bar. We'll see now we are going to get y bar. So x bar is, by definition, when we were doing it along the x-axis, isn't it? How was x bar along the x-axis? Meaning we are now dealing with the y bar along the x-axis, isn't it? Y bar along the x-axis was given by a half, then we were integrating from a to b of y squared dx over integrating from a to b of y dx. I've just gone to the definition direct, isn't it? Yeah, if it was y bar, here was y dx, then you multiply the numerator by y, isn't it? Are we together? But now, in this case, we are integrating with respect to y, because the limits are y. Meaning where there is x, we put y, where there is y, we put x. So, where there is y, we put x, where there is y, we put x, where there is y, we put x, where there is x, we put y. So, have you seen, the x bar is taking definition of y bar. Have you seen what I'm doing? You are very happy about it, isn't it? Good. So if you look at this, even look here. Are you seeing the x bar? See, x bar is just a half is left. X bar is just a half of the whole of this. Are you seeing? Yes. That's the reason why I was coming with this case, so that you are able to see when I will be transforming them, isn't it? You can see x bar is just a half, but it's supposed to be the whole of it, so it is just a half. See there? Good. So we have x bar is a half from a to b of x squared dy over a to b of x dy. So what is a to b? The limits a to b are the limits of y, because we are integrating with respect to y, isn't it? Yes. The limits a to b are now limits of y. So it means it is the y which is in the limits a to b. Very good. So, what do we do? Are we together? Good. What we do ladies and gentlemen, we start with the first one, y bar. So y bar we are integrating. We don't need to get y bar. We need to get each and every term separately first, isn't it? It's when we bring them together, isn't it? So we can start by getting what is in this denominator, because this denominator is the same for both of them. You can see the denominator is the area, isn't it? Are we together? The denominator is the area of that region. So that denominator, which is given by integrating from a to b of x dy, is what? Your limits of y from a to b is from 1 to 8, isn't it? Are we together? Then what is your x? Remember, what is your x? Look here. Y, look at this. Y is equals to 6x squared. Are you seeing? So if y is equals to 6x squared, what is x? You divide both sides of the equation by 6, isn't it? So that you get y over 6 is equals to x squared. Then you find the square root on both sides, isn't it? Are we together? You are making x a function of y. You are getting the concept? You find the square root on both sides. So you get x is y raised to power half over 6 raised to power half. The square root on both sides. X is y over 6 raised to power half. Can you go to the calculator? Meaning where there is 6, because everything must be in terms of y. Are you getting it? Good. So that is going to be y raised to power half over 6 raised to power half. What is the square root of 6 in the calculator? That is the reason why we were told to do it in 3 decimal places, meaning there were decimals going to come here, isn't it? 6 raised square root of 6? 2.4? 4? Just like that? Are we together? Yes, so it means your equation, which was y is equals to 6x squared, if you make the x the subject of the formula, you get x squared is equals to y over 6. You find the square root on both sides. So you get x is the square root of y over square root of 6, isn't it? Are we together? Good. So can you take this one outside? You are integrating it with respect to y, because the limits are y, isn't it? With respect to y. I have factorized outside. What do we have? What do we have? Start. The constant here is 1 over 2.449. That is constant, isn't it? See, you take it outside. Are we together? Then if you integrate y raised to power half, see, you add 1 to the power, you get 3 over 2, then you divide by that certain power 3 over 2. You add 1 to the power if you want to integrate a polynomial, isn't it? This 2.449 goes outside, you factor is outside. So if you integrate y raised to power half, you simply add 1 to half, that is 3 over 2, then you divide with that 3 over 2, isn't it? Are we together? Then we are integrating from 1 to 8. What do we get? What do we get? I start. What is the first thing you do? So you take this constant outside. So that is going to be, this is what you do. 1 over 2.449 divided by 3 over 2. Because 3 over 2 is in the denominator, isn't it? 1 over 2.449 divided by 3 over 2. Divided by 3 over 2, you have 0.27. 0. Meaning 1 over this divided by this 0.2. Remember when you are dividing like this, 2.7 like that, isn't it? Remember 3 over 2 means, it means this 2 is coming back in the numerator, isn't it? So it is like 2 over 3 times 1 over this, you still get the same thing, isn't it? Good. So that one is that. Then in bracket we now have y raised to power 3 over 2. We are integrating from 1 to 8. Can you integrate it from 1 to 8 and give me the limits? The upper and the lower. So the upper minus lower, isn't it? So when y is 1, 1 raised to power anything is 1. The lower limit will be 1, isn't it? See, when you substitute 1 here, see, it is 1 raised to power 3 over 2. See, 1 raised to anything is 1. See, it means the lower limit will be 1. Then the upper limit, where there is where you put 8, isn't it? Are we together? So what is 8 raised to power 3 over 2? To get the upper limit, 8 raised to power 3 over 2. 8 raised to power 3 over 2. 8 raised to power 3 over 2. 22.6. 22.2. 6. 27, isn't it? Are we together? So can you now take upper limit minus lower limit times that 0.27, and you confirm, if you use another method, you confirm if you have the same answer, isn't it? Because there are people who you keyed in direct, and you got the answer, so we just want to confirm. Can you give me 22.627 minus 1 is 21.627 times 0.272. What do you have? 21.627 times 0.272. Using the other method, you are supposed to get 5.883. Is that what you are? Very good. 5.883, 3 decimal places. Are we together? 5.883. Is that okay? So that is the first thing we found. The first thing we found is this denominator. Is that? Is that understood? So it means this our denominator, this integral of a dxy, this one we found, it is 5.883. This denominator here we found it is 5.883. Now we go to these numerators. Are we together? Good. Are you seeing the way we are organized? Very organized. Look at this one. Which one is easier? This one is more easier. We deal with this, isn't it? That one is more easier. So start. When you have a half, then you are integrating from a to b of x squared dy. You just substitute, isn't it? Okay? So this is equals to what? A half. The limits a to b is 1 to 8, isn't it? Then what is x squared? Check your function. Your function is y is equals to 6x squared, meaning you make x squared the subject, isn't it? So if you make x squared the subject, you divide both sides by 6, meaning you get x squared is y over. So where there is x squared, we put y over, because we are integrating with respect to y. So this x squared must be y, isn't it? So x squared is y over 6. So that is y over 6 dy. Are we together? So start. I have 1 over 2 divided by 6. We are removing that 6 outside the bracket. 1 over 2 divided by 6. You get 1 over 12. 4 just 2 times 6 in the denominator, isn't it? 1 over 12. Then we are integrating from 1 to 8 of y dy. So what do you get? 1 over 12 into, if you integrate y, so you get y squared over 2. If you integrate y, so simply add 1 to the power. 1 plus 1 is y squared over 2. Then you put your limits. It's from 1 to 8. Good. So we are integrating y with respect to y. Y is raised to power 1. If you integrate it, it is 1 plus 1. 2, then you divide by that 2. Polynomial. See there? Good. So if you take these 2 outside, what do you have? So you have 1 over 24.
1 over 24.
Yes, go on. 1 over 24 into. This is 1 over 24. Then we have into y squared from 1 to 8, isn't it? So that is 1 over 24. Then upper limit minus lower. So if you substitute 8 here, 8 squared, you get 60. 64. You're done with the upper limit, isn't it? if you substitute 1 here, 1 squared you get? Are we together? So 64 minus 1 is 63. So 63 times 1 over 24 is like 63 divided by 24, isn't it? Which is 2.625. Did you get that using the other method? 2.625. Are we together? Good. So it means this a half x squared dy, this a half x squared dy, the whole of this numerator, we found it to be 2.62. This one, the whole of this, we worked it out and we found it to be 2.625. So have you seen we found the value of x bar? 2.625 divided by? Are we together?
Yes.
We just substitute because a half integral of x squared dx we found is 2.625. It was here. We've substituted that one. We now want to get this one, this numerator, the whole of this. Then we substitute it there. Here. If we integrate y squared, see we've already integrated y, we found y squared over 2 and we've taken 2 outside. Here. Here, 1 over 12 divided by 2 is 1 over 24. We remain with y squared inside. See, you substitute the limit when y is 8. So it is 8 squared. 64. Then when y is 1, so it is 1 squared, which is 1. So upper limit minus lower limit, so you get 63. Then we multiply by what is outside, 1 over 24, isn't it? Good. Go on. The next one. We are left with 1, isn't it? We are left with this numerator. Let us deal with that numerator. You can see how doing this centroid is very enjoyable, isn't it? It is very enjoyable because it is very systematic.
Yes.
Yes. So go here. You are integrating from A to B of xyd dy. Are we together? When we are integrating with respect to y, it means this x is what we need to remove, isn't it? So what is this x? We know y is 6x squared. Y is, we were given our curve here is y is 6x squared. So we want to make x the subject, isn't it? So if you make x the subject, what do you get? You divide both sides by 6, first of all, you get y over 6 is equals to x squared. So for you to get x, you look for the square root of both sides, isn't it? That is going to be square root of y over square root of 6 to be equals to x, isn't it? Are we together? So what is the square root of y? What is the square root of y? The square root of y means y raised to power half, isn't it? Then what is the square root of 6? 2.449 is equals to x. So it means where there is x, we put the value of x. Everything must be in terms of y because we are integrating with respect to y. Are you seeing that? Is that okay? So this one is equal to be equals to, we are integrating from A to B, and this x, we found it is the same as, that x is the same as y raised to power half over 2.449, then y dy. Are you seeing now everything is now in terms of y? We can only integrate with respect to y if everything in terms of y. So we remove this x. And this is the equation giving us the relationship between x and y, isn't it? Is that understood? Good. Now after that, so you just use the laws of indices to deal with that. So move on. Take this one outside, the constant outside. You have 1 over 2.449. Then we are integrating from A to B. What are our limits? 1 to 8. Are we together? Then y raised to power half times y. That is laws of indices. Same base, you add the powers. This is y raised to power 1, isn't it? So y raised to power half times y raised to power 1, you get y raised to power 3 over laws of indices. You add the powers when you have multiplication at the same base, isn't it? So you have y raised to power 3 over 2, then we are integrating with respect to y. Very neat work. After doing that, we just do the integration now, isn't it? We'll do the integration now. So we have 1 over 2.449. Then in bracket, if we integrate, we simply add 1 to the power and we divide with the resultant power, isn't it? Yes. If you add 1 to the power, you get y raised to power 5 over. Then you divide by 5 over 2. Then you put your limits of integration from 1 to. Yes. So start by getting for me that constant which is outside. That constant which is outside is 1 over 2.49 divided by 5 over 2. What do you get? This, if you divide by this, you get? Because it is in the denominator, that's what you are dividing with, isn't it? So this 1 over 2.449 divided by 5 over 2, you get? What is the constant you get? 0.163. 0.16. Then inside we remain with y raised to power 5 over 2, then we integrate from 1 to 8. So we remove that constant outside, isn't it? Are we together? What is outside here is 1 over 2.449. Then this 5 over 2 is in the denominator. See, what is the denominator? It means we are dividing with. So it is 1 over this divided by 5 over 2, you get 0.163. Then now we want to substitute the limits when y is 8 and when y is 1, isn't it? Are we together? So what do you get? 0.163 into upper limit minus lower limit. So lower limit is direct. When y is 1, you have 1 raised to power 5 over 2. 1 raised to power anything is just 1. You're done with the lower limit, isn't it? Are we together? Upper limit 8. When y is 8, 8 raised to power 5 over 2? 181.019. 02 is okay. Are we together? So 181.02 minus 1, then times that, would you get? 180.02 times 0.163. If you subtract 1, it remains 180.0, isn't it? 180.02 times 0. What do you get to the answer? 29? 29.3? 337, it means 34, isn't it? So what have we found? We found the integral of x, y, dy. We found the whole of this numerator, isn't it? Are you seeing that? Yes. So the whole of this numerator, the whole of this value, we found it to be 29.343. 337.
You do what the examiners.
3, they say 3 decimal places. Okay, that is 29.3? 337.
Yes.
Very good. So that is 29.337. 3 decimal places. So after doing that, see we get the x bar whatever. Hello? See we want the x bar, the centroid, the position. You've seen a movie around the graph the x bar. What did you write here to be x bar? What did we find x bar to be? 2.625 over the area, isn't it? Over 5.883. That was x bar. And y bar we found to be 29.337 over 883. So what do you get with this answer? Hello? What is x bar?
4.9.
X bar is equal to 0.
It cannot be 2.65 divided by 5 is
0.446.
446. Look at that. Very neat work. Then here, this is 2.6525 divided by 5. Oh, the second one is 4.987. Now look at the centroid. Now you can even see the y bar which is between here. It is between 1 and 8. The value between 1 and 8, 4.9 is between 1 and 8. Meaning you are able to prove that those answers are correct. You see? So you are seeing the y bar is reading at this point here, isn't it? Yeah. So are you seeing that point? It is a value which is between 1 and 8. Yeah. Are we together? And you can see the x value is reading somewhere here, which is approximately 0.446. Any x value is making sense. You know, when y is 8, you are able to see what is the x value at this point. When y is 8, if you put 8 where y is, what is x? Go to the calculator. When you put 8 where y is, you get 8 is equals to 6x squared, isn't it? Divide both sides by 6, you get x squared is equals to 8 over 6. Then you get x is the square root of 8 over 6. So get me the square root of 8 over 6. Meaning the value of x here is 1.154. So see what we found the value of x bar. See 0.44 is some value between here. Are you seeing? So yes. So if the value if y is 8, we found x is 1 point. This isn't it. But you can see how where our x bar is reading here. See that value is approximately 0 point something. Yes. You're very correct. Yeah. And that is how you handle that given problem. Very simple, isn't it? Very simple. It has a lot of marks. That is why.
How many marks?
It has a lot of marks.